Years ago, geothermal systems supplied heating for homes with simple applications. You would open a valve and let hot water flow through piping installed in the home. These systems were only available in a small portion of the country. Glenwood Springs, Colorado is one of those locations where the spring water runs between 90 and 122 degrees Fahrenheit year-round. As we advanced in heating and cooling technology, we learned that buildings could be heated and cooled using a ground source heat pump. These systems were called geo-exchange systems, which exchanged temperature from the earth to the building and the building to the earth. In the winter, the cool temperatures in the building are exchanged with the warmer temperature in the earth, and that is reversed in the summer months. In Lafayette, Colorado, the ground temperature at a depth of 8 feet in the earth generally stays around 58 degrees Fahrenheit. Currently, these systems are referred to as ground source heat pump systems. The heat pump's main component is the compressor and is basically the same type of system that you have in your home refrigerator. But in the winter, the system's cycle reverses to supply heat. Now let's take a look at the basic schematic of the heating cycle. Let's start where the fluid enters the building and goes through the heat exchanger, where the cold liquid refrigerant gets changed to a cold vapor. The cold vapor is then heated in the compressor, where it becomes a hot vapor. Please disregard the DHW tank in this illustration. We have a separate electric hot water heater at the fellowship. The hot vapor is sent to the air heat exchanger. The air in the building is blown across the heat exchanger, and the warm air is then sent into the building to warm the space. At that point, the hot vapor is transformed to a hot liquid that is sent to the thermostatic expansion valve, which changes the refrigerant to a cold liquid. Then the cycle repeats. Please note that the refrigerant used in the system is R410A, which has a boiling point of minus 55 degrees Fahrenheit. Now let's discuss the cooling cycle, and again let's start where the fluid enters the building. The hot vapor goes through a heat exchanger, which changes the hot vapor to a hot liquid. After going through the thermostatic expansion valve, the hot liquid is changed to a cold liquid. When it enters the heat exchanger, the air in the building is blown across the heat exchanger, which supplies cool air to the building space. At that point, the cold liquid is converted to a cold vapor that is sent to the compressor. The compressor converts the cold vapor to a hot vapor. Once again, please disregard the DHW tank in the illustration, as we have a separate electric hot water heater in our building. The hot vapor then enters the heat exchanger, where it changes to a hot liquid, and the cycle continues.